Hello and welcome to Modular's Max 25.2 live stream. My name is Caroline Frasca and I'm Modular's Community Manager. We're so glad you're here with us today. We've got a ton to share and we're excited to walk you through everything that's new in our latest release. Here's what's coming up today. First, we'll hear from Tim Davis, co-founder of Modular, who will explain why Max 25.2 is such an important step forward. Then we've got a special segment recapping NVIDIA GTC. So if you didn't make it to the event this year, we'll show you what you missed at the Modular booth. After that, Connor Gray, Mojo Standard Library Engineer, will break down the latest and greatest in Mojo 25.2. Next, we'll hand it over to Brad Larson, Product Manager, to walk us through the key updates in Max 25.2. And finally, we'll wrap things up with a live Q&A. So if any questions come to mind while you're watching today, just drop them in the chat and we'll answer them during Q&A. Take it away, Tim.
Hey everyone, I'm Tim, one of the co-founders here at Modular. A little over a month ago, we introduced Max 25.1, which marked an important step forward in how teams deploy and scale Gen AI. Laid the groundwork for something bigger, and we're excited to talk about that today. I'm proud to introduce Max 25.2, a major update that unlocks industry-leading performance on NVIDIA H100 and H200 GPUs without CUDA or any associated libraries, and only requiring the NVIDIA GPU driver. That means no CUDA toolkit, no version mismatches, no heavy runtime baggage, no bloated Docker containers. Just lean, powerful, performant, and reliable AI infrastructure. This enables us to unlock native hardware portability, and we have many exciting updates that we'll talk about in that regard in the future. Max 25.2 powers faster, more responsive, and more customizable Gen AI deployments at scale. With this release, you'll get state-of-the-art H100 and H200 performance with support for more than 500 Gen AI models like DeepSeek, Gwen, QWQ, and more. Multi-GPU support for massive models that go beyond single GPU memory like Llama 3.3 70B and more. LLM serving improvements that cut latency, boost throughput, and make better use of your hardware. A new 1.3 gigabyte slim Docker container, meaning deployment is faster than ever, made possible by not including CUDA. And advanced features such as GPT-Q quantization to run bigger models more efficiently than ever before on memory-constrained GPUs. We've also continued investing in Mojo, our next-gen programming language, which gives you the ability to write GPU code with incredible performance and beautiful usability. With Mojo, you won't ever have to touch CUDA again. If you're already using Max 25.1, this builds directly on everything you've already put in place. And if you're just getting started, now is the perfect time to dig in. Head over to modular.com to check out the release, read the docs, and connect with others who are building the next generation of AI systems. We've come a long way, but we're still just getting started. And we have incredible updates dropping nightly, so come build the future of AI with us.
Thank you, Tim. Now let's take a quick detour to NVIDIA GTC. If you couldn't make it this year, we've got you covered. Here's a recap of what you missed at the Modular booth.
Hi everyone, my name is Deep. I'm a software engineer on the cloud inference team at Modular. I'm so excited to be at NVIDIA GTC. Let's show you our booth. Here's our booth. We're so excited to show you what we're working on. See ya.
And so what we're doing is we're building this whole new world without CUDA. We think this is a big, bold bet. This is a very important thing. We think this will unlock a huge amount of power, a huge amount of applications, things that people can't even imagine. And what I believe truly is that if you get people able to use and innovate and work together with all these layers of the stack, because you understand it, it's an open box, it's not taken away from you, then we'll see even more research, even more applications, even more cool business use cases. A new community can form where we can bring together all the smart minds and actually unlock this thing and like get us to the next level.
So the difference is we can get you across the different types of compute. And then we enable you to control the stack all the way down.
Max has a very simple layered architecture stack, and it's actually designed together by a unified team that is built it for Gen AI, for modern hardware, and for novel applications, also a way that can scale.
All of the models at peak performance.
Yeah.
And the win you get is you get compute portability. We built an AI GPU software stack without CUDA.
Mojo is the world's first language designed for heterogeneous compute. I have not seen a single other booth where people will actually telling you how to program a GPU instead of just like layering some stuff on top of a cloud platform. And I mean, that's cool and very important. But GPU programming is really important. Like all these slots, they need to go burr.
We are just as performant as CUDA. So you get the performance of NVIDIA, but the optionality of other compute. What that gives you is lower TCO, which is what you care about, right? You just get cheaper compute, basically. We actually have a program right now. You can get 4 weeks of free H200 support just to try the platform and work with us.
It's a huge amount of work, but by making this kind of investment, we think we can actually lift the ecosystem. We can bring people together.
So awesome to see the energy from GTC. Now let's shift gears and dig into the release. Joining us is Product Manager Brad Larson to walk us through the key updates in Max 25.2 and what they mean for you.
Hi, I'm Brad, and I'm really excited to once again share what we've been working on in Max. We have another long list of big new features in Max 25.2, so let's dive into them. These include new NVIDIA Hopper GPU support, running big models across multiple GPUs, and a lot more. As always, check out the detailed What's New document for a complete breakdown of all the changes, from big to small. We'll go through some of the highlights of this release here. To start off, we've added support for a new NVIDIA GPU architecture to Max, Hopper. We've had a lot of interest in running Max on H100 and H200 GPUs, and now you can use Max to get the most out of these GPUs for your AI workloads. As a personal note, anyone who's worked on Hopper GPUs can tell you how really tricky they are to program. It's been amazing to me to see how quickly Modular's team was able to build out support for this architecture in Max. Beyond just making the stack work on these GPUs, this included pushing the performance of matrix multiplication and Mojo kernels to levels competitive with cuBLAS, building our own optimized Flash Attention 3 kernel in Mojo, and plenty of other tricks on the side to boost performance. It's a really great demonstration of how the fundamental technologies we've been building at Modular allow us to very quickly adapt to new hardware architectures, even as something as complex as Hopper. This new Hopper GPU support is coupled with another major milestone, the ability to serve models that only fit on multiple GPUs. For example, you can now serve the 70 billion parameter Llama 3.3 model with very long context lengths on multiple H100 or H200 GPUs at a throughput that meets or exceeds frameworks like VLLM. This fundamental new capability unlocks the use of Max in entirely new domains that use the largest open source models. Today, initial support for tensor parallelism in Max models is present in the Llama family of architectures, but model support will expand out from there. To make larger models fit in more limited GPU RAM, we also now support GPT-Q quantized models on GPUs. As an example, this lets you squeeze an 8 billion parameter model to fit in only about 5 gigabytes of RAM, which could even work on common consumer-grade GPUs. This support should be largely transparent in use. Simply point to a GPT-Q quantized model on Hugging Face using the Max pipelines and just go. We're continuing to roll out examples, APIs, and documentation for all of the different ways you can program GPUs using Mojo. It's an extremely exciting capability, and you can tell from how much we've talked about it in this presentation and elsewhere. In this release, we've shown more of the GPU programming experience that Max and Mojo can provide by rolling out examples of writing and dispatching GPU functions directly from a single Mojo file. This is a programming model that's very familiar to CUDA-C programmers, where we've even recreated the first 3 examples from the popular textbook, Programming Massively Parallel Processors, in Mojo, so you can see how concepts you may be familiar with map to Mojo GPU programming. We've also started to add examples and documentation for our memory layout abstractions that make it easy to achieve state-of-the-art performance on GPUs while having clean and readable code. But keep an eye out for more in this area. Try all of these examples today in our brand new recipes on builds.modular.com, where you'll find detailed readmes walking through basic GPU functions, optimizing matrix multiplications for GPUs, and more. We also have a comprehensive new GPU programming manual in our Mojo documentation that introduces many fundamental concepts. Along with new ways of programming GPUs, we've significantly improved the developer experience around writing custom operations in Max graphs by removing boilerplate and enhancing type safety around these operations. This is a source-breaking change, so please see the release notes for how to migrate your existing custom operations. Max as a platform does not rely on vendor-specific libraries like cuBLAS or cuDNN, so we can produce a very small Docker container with everything you need to serve models on NVIDIA GPUs. This new lean Docker container weighs in at about a gigabyte in size and should help with fast spin-up of new Max serving instances. We, of course, keep working hard to drive forward performance across the stack, with some of the most visible enhancements in 25.2 coming at the serving layer. Batch scheduling has been extended to account for prefix caching, which can lead up to a 10% improvement in throughput. The addition of in-flight batching drives down inter-token latency, and copy-on-write KV blocks improve overall serving performance by optimizing cache hits. Again, all of this should be largely transparent when serving with the Max 25.2. You'll just notice a boost in serving throughput when upgrading. We rolled out Max builds in our last release and now have over 500 models listed there, most of which are fully optimized for Max. At least 5 entirely new families of model architectures are now supported in Max as of 25.2, including the extremely popular Qwen 2 and Phi 3 architectures. Go to builds.modular.com to see the full list. We're adding new models each week. That's a lot, but there's even more in Max 25.2, from improvements to how model weights are downloaded to fundamental advancements in how the computational graphs of models are compiled and cached. Please do check out the What's New section in our documentation to see the full list, from big to small changes. I encourage you to try out all of the new capabilities and examples, and join us at forum.modular.com to talk about how you're using Max. Thanks, and with all that said, I'll hand you back to Caroline to continue with the rest of the stream.
Thank you, Brad. Really exciting progress with Max 25.2. Now, for those of you working in Mojo, you're in for a treat. Let's hand it off to Connor Gray, Mojo Standard Library Engineer, to highlight what's new in Mojo 25.2.
Hello, everyone. I hope you're enjoying the 25.2 live stream so far. For folks who don't know me, my name is Connor. I work on the Mojo Standard Library, then giving a general update about everything that's new this release in Mojo. For folks who weren't here during our last release, that was 25.1. There's a lot of great stuff in that release. Among other things, that was a release where we added some initial support for GPU programming in Mojo. This release, we've got some great new stuff that we'll be talking about. I'm just going to do some quick hits, though, on all the new things Mojo and Mojo Standard Library. So kind of highlights, we've got some new stuff in the Mojo manual. It's all about that GPU programming functionality that we're continuing to build out. As we mentioned here, there are some APIs, or a lot of APIs that are in the GPU package that we've enhanced, made some improvements to, so stay tuned for more and more work in that area. Now some changes to the Mojo language. Folks who've been using Mojo for a while are probably familiar with this borrowed and in-out keyword argument convention. We've made some renames based on some design interaction with the community to improve kind of the learnability of these keywords. The old syntax has now been fully removed. The new syntax is pretty great, so I hope everyone's migrated over to that by now. Another area of improvement in this release is that the Mojo string types have gotten a lot better. This is something I've worked on and others in the community have helped out a lot with. Basic TLDR, Mojo string types are now fully UTF-8 compliant for the most part. The APIs working with them are a lot safer. It's hard to get undefined behavior and weird issues with your string types. We've added support for new 128 and 256-bit integer types. So these are particularly useful for folks with specialized use cases, things like hatch implementations and the like, where you really want large integer types that make it more natural to express some logic in those specific domains. So moving on to more changes in the Mojo language, there are a couple things here. The big one I want to call out is that we've made some improvements to the number of LLVM intrinsics that can be handled by our compile time interpreter. For folks who don't know, the comp time interpreter is the feature of the language that actually allows you to run arbitrary Mojo code at compile time. This is what powers Mojo's very expressive, very powerful parameter system, somewhat some people might call like compile time generics. This is important because there are a number of places, especially in the Mojo standard library, where we have implementations that use optimized LLVM intrinsics for, things like, what springs to mind for me at least is UTF-8 decoding, for example. Historically, some of those intrinsics have not been supported by the comp time interpreter, which meant that we couldn't always use LLVM intrinsics in all the places we wanted to. We now support more intrinsics, and we also have a feature in the language to allow code to branch and choose a different implementation depending on whether it's being compile time interpreted or whether it's actually being compiled to machine code that'll then run at runtime. So that's a small but very, very important power user feature that helps us write the standard library and helps make Mojo code as fast as it possibly can be. And let's pick the best implementation for the situation we're in. Another this is slightly subtle feature, but references to alias and struct types that have unbound parameter sets are now allowed. This is a bit nuanced to the feature, but it's really important for modeling certain kinds of relationships between structs and the aliases that they've got. Hopefully for folks who've been waiting for this is like, yes, this is a great moment to have. So moving on now to standard library changes. We've made some improvements to how the int literal and float literal types are implemented. The basic idea is that these types now have no runtime value. And this is kind of been a hole in the compiler up to now. You could run into certain errors if you tried to use these in ways that weren't supported. With this change in design, it's now harder to misuse these types. And it also opens the door to future improvements down the line. Long story short, what was previously a field on the int literal or float literal types is now a parameter. That means that we're actually leveraging Mojo's parameter system to model int and float literal types fully at compile time. This is kind of a nice cleanup in the conceptual model of how these types work and how the language in general works. These are clearly such fundamental foundational types for Mojo. Another change here is that folks may be familiar, we've had a buffer type for a long while. That struct has now been removed in favor of either using the span view type or the ND buffer type. This is just part of us, as Mojo has matured, we've gotten more experience designing our APIs, factoring things a bit better. We're simplifying how these types work and relate to each other. Additionally, the optional span and inline array types that have been in the standard library for quite a while now are now in the Mojo prelude. That simply means that if you're using these types in your code, you no longer have to import them explicitly. They'll just be visible to your code and you can use them. And that's quite nice because these types have become quite common in Mojo code. So not having to import them removes a certain amount of work that programmers have had to do. Additionally, we have a new interval tree data structure in the Mojo standard library. Then again, this is a kind of specialized data structure, but for folks who need this, hopefully this will be really nice to have. This is useful for efficient range queries. This is just part of the standard library, so you can import it from our collections module. Let us know if you guys have any feedback on this. We want to make sure that Mojo has the best implementations of all the data structures that folks care about. Moving on, some additional changes in the standard library. The char type has been renamed to code point. This is just to clean up, making sure that the names of our types more closely align with the underlying Unicode standard that we follow in our modeling string types. Additionally, string slice now supports many additional methods that previously only existed on string. This is important because our string type is a heap allocated string, which means that if you have a function, say, that takes a string, users of that function would always have been required to allocate a string before they could call your function. And that's not necessarily optimal because they may, have a string that's not necessarily on the heap or is borrowed, maybe it's, static data, something like that. So making string slice more powerful allows us to migrate more methods, both within the standard library and within the broader communities, code bases, Mojo code bases, away from requiring string and towards requiring this lighter weight, more flexible string slice type. So this is just another quality of life improvement there. Additionally, the linked list collection we've had for a while now in the standard library now has a forward iter method and a reversed iterator via its reverse method. This is just a quality of life improvement, making it a bit easier to work with the linked list type. Should be good. Continuing on now to changes related to GPU programming in Mojo. As I mentioned at the top of this section, GPU programming is something that's relatively new in Mojo. We had some initial support for that in the previous 25.1 release not even that long ago, back in February, middle of February. So we're following that up now with some more improvements. There's an important UX improvement for anyone writing GPU kernels in Mojo. This allows us to cut down further on some of the boilerplate. Mojo is already really good about minimizing boilerplate when it comes to working with, such a powerful feature like GPU programming. We're just continuing that process of, refining, making these APIs easier to use and less, minimizing boilerplate to the extent possible. So this change here specifically is that previously, if you had a kernel function written in Mojo, this is a function that you're running on the GPU device, you had to, in a two-stage process, compile that function to native code for the accelerator you're targeting, and then schedule that function to run on the accelerator, on the GPU. Now we've just kind of combined those APIs together because it was often sort of redundant to require you to specify both things as separate steps. So now that's just a single call. So as you can see in the example here, launching a GPU kernel on Mojo is simpler than ever. It's really just one line now, just to queue your function, and you're off to the races running some code on the GPU. So that's really, really quite clean. So hopefully relatively quick hits on some of the most important things that are new in Mojo 25.2. But as always, there's tons and tons and tons of minor improvements and polish changes that the team's been working on over the last month. This incorporates a lot of community contributions as well. So I encourage everyone to go read the changelog and see all the great work that everyone's been up to. Thanks.
Thank you so much, Connor. Those were really awesome updates in Mojo 25.2. And with that, we've covered all the highlights from Max, Mojo, and GTC. And I want to take a second and say thank you to everyone watching for sticking with us through some technical difficulties. Wouldn't be a live event without a few technical glitches. But now we're going to get into the fun part of today's event. We're going to bring the rest of the team on stage to answer questions from the audience. Awesome. So to kick it off, our first question. Our first question comes from 0xBA1. And the question is the complete open sourcing of Mojo a certain thing, or is it something you simply plan to do in the future? I'm asking because the Mojo license FAQ page doesn't fill me with confidence.
Okay. So yes, we definitely plan to open source Mojo, the compiler. We have the standard library that's already open sourced. We have a lot more Mojo code that we'll be open sourcing actually pretty soon. So we can't announce that today, but stay tuned the next month or two. We'll have some really exciting stuff to share.
Thank you. Our next question comes from Gregor. Is Mojo going to fully support also just-in-time compilation, e.g. for hot reloading?
I actually have no strong idea. So there's a bunch of different ways to support this. LDB has some support for that, which we use for a variety of purposes, and you could do some amount of monkey patching and vtable hacking and all that kind of stuff. It really depends on the use case. So I can't give you like a really general answer, but anything you could do with a language like C or something like that, we can totally do with Mojo too.
Thank you. What are some upcoming features we can expect to see from Mojo?
So we still haven't published a Mojo roadmap, but what I can say about the language is that there's a bunch of stuff coming together. One of the things I'm hoping for is support for required clauses. So being able to say, instead of saying that you constrain something and then it fails with kind of an ugly error message, making it so you can add a requires clause onto a method, and then it's only available, for example, on SIMD, it only works with floating point literals if the D type is a floating point type. A lot of behind the scenes work has been happening on improving dependent types and a lot of the underlying infrastructure and how parameters get materialized and a lot of this kind of stuff to make that possible. And so the team's scoping that out right now, and we'll see if this enters the nightly soon. I think that'll be a huge step forward in terms of library design and things like this. Beyond that, string literals, there's lots and lots and lots of other improvements that are happening. One of my most excited pieces is improvements to closures, actually. And so right now you have to use the parameter keyword above a lot of nested functions. And so I think that that's going to get fixed. There's like a couple of types, memory safety holes that will get closed up. I don't know, but I hope that finally we'll get Lambda syntax. So there's this whole thread on closures that are going, and there's a ton of other work. So the team's working really hard on that.
Awesome. Thank you. When AMD GPU is the next question.
Tim, you want to take this one?
Yeah. Hey, everyone. We don't have anything to announce on that yet. Hopefully it's, folks know we're working hard on a lot of different alternative compute platforms. I think when we are ready to announce it, I can say with confidence it will be very loud. But right now, yeah, nothing to announce. But maybe to hint to some degree of excitement, we are definitely working on other platforms, and so you should rest assured that we're as interested as everyone else is. And when we have more to say, we'll come back, and hopefully you'll be here on the live stream with us as we do it. So that's probably all we'll say right now.
Yeah, all I'll add is that I'm pretty interested in us democratizing AI compute.
And if you haven't checked out the blog post, go check it out. Blog post series.
The blog posts right now are mostly about the depressing past, not about what we're doing about it.
Next question. Is implicit conformance to traits via decorator, as with copying, considered? I think that's kind of a follow-up question to the
implicit conformance to traits. So I can't tell you the answer to this on the fly. The team right now is looking at implicit trait conformance, which Mojo already does support, and is trying to decide, is that a good thing or not? And so there's a predictability trade-off and things like this that people are looking at. As we look ahead and we're looking at more advanced generics features, I think they're looking at proper conditional conformance that's declared and modeling that the right way. And I think that's really important for us to be able to model. And so to give you an idea of what that would enable, you'd be able to say like a list is comparable if the elements are comparable. And so we want to make sure that we can model that kind of a thing directly in the language and make it all type safe and all checked and good error messages and all this kind of stuff. And so I think that they're looking at implicit conformance and trying to decide, is implicit conformance the right thing or not? And we kind of added it, gosh, a year ago or something, when a lot of other features in the language were missing. And so now that the language has grown up quite a bit, the team's looking at that again. So I don't know the exact status of that, but a lot of these features are really coming together, and we're investing a lot in making generic programming really powerful, and even more so.
A slightly random question. How does the mission of the Max/Mojo ecosystem compare with TinyGrad?
I love George Hotz. He's such an exciting character. I don't really understand what the TinyGrad mission is. I understand the claims he's making. I think that we're very focused on delivering GPU performance. I think that from what I understand of TinyGrad, he's trying to like prove a very small Python code base can generate code. And so I think there's similarity there where we both want things to be easy and we want portability across AMD and NVIDIA and things like this. And so I think there's some commonality there, but I think that we're taking a very pragmatic approach. And so like you can try Max on an H100 and it delivers basically the same performance as TRTLM without using any CUDA. And so as far as I know, the performance that you get with TinyGrad is not there yet. On the other hand, TinyGrad's cool if you want a relatively small code base and that's what you're looking for. And so it's a really cool project, but it's hard for me to know kind of where TinyGrad grows up to and where they're going.
Does Mojo ever plan on supporting calling Mojo code from Python? Would be really nice to use Mojo to replace C Python.
Connor, what do you think?
Short answer is yes. That's definitely something we want to do. I think I don't have a lot to say yet, but stay tuned. There'll be more to say.
Come on, Connor. Come on.
Okay, well, I mean,
You're among
give
friends.
a little more
You
detail.
can share a little bit.
Yeah, I mean, I can say that this is a project that is being worked on. We do want to deliver something in the foreseeable future. Let's say I won't promise specifics. I think particularly what we're targeting is the ability to. I mean, in the long term, we want this to be seamless, right? We want Mojo to have better ability to be used from Python than any language out there, right? We really want this to feel like, as we've talked about before, Mojo is a sibling to Python, right? It's like the best language to extend Python. That's the UX we want to get to. In the short term, we're probably going to be focusing more on enabling use cases a bit quicker. So you might have to write some little bit of boilerplate, but we'll get this feature out there and we'll iterate and improve as time goes on. So,
I'm really excited about this work. I think this is going to be a really big deal, and it will help a lot of people be able to adopt Mojo into existing Python code bases. But what Connor's hinting at is this isn't like one feature. It's a step and a step and a step and a step and a step. So.
Yeah, which I guess I'll just add to that. I mean, as people who've done language interrupt before know, it's a hard problem. Impedance mismatching between the different ways languages work. We really want to nail this, so this is kind of a long-term bet for us. We want this to feel really great because it's a massive unlock, as I think the question hints at, when you can do this in a seamless way and you can really feel like there's no friction, going between languages.
Thank you. Do you plan also to support more consumer GPUs like 50X or 40X?
Brad, take it away.
Yeah, I mean, so we've talked about this, I think, in previous live streams. We've been very conservative about our messaging around GPU support, like officially claiming support for the things that we run regularly every day in CI, the data center GPUs. We have support in Max for Ampere, Ada Lovelace, and as we've talked about today, now Hopper GPUs, and that includes like consumer grade GPUs across those ranges there. So the RTX, 30XX series, 40XX series, and in fact, as I posted over in our forums, we just added support for the Jetson Aura Nano devices, which are Ampere class single board computers, and so. All of these, you can do all of the GPU programming you want to on there, run models on them, and so forth. And as we know, like the Blackwell is an important architecture, so we're definitely going to take a look at it in the future. But we're progressively rolling out support for each one of these architectures. But yeah, if you do have an RTX 30XX, 40XX series, try it on Max today. It works great.
Cool. Does Mojo support that language to CUDA SSA?
I assume this is SAS, maybe? To CUDA SAS. So Mojo works by compiling to what's called PTX. And so PTX is the documented or mostly documented standard for talking to NVIDIA GPUs. And so we bypass the CUDA libraries. You can use them with Max if you want to call into legacy CUDA kernels, then you can do that also. But when we're building, what we're focused on is enabling this full stack compilation flow that enables you to get the most out of the GPU. And we build all of those libraries out of Mojo. And so we go to PTX. We don't go down to SAS, which is the not really documented in NVIDIA thing that I think is widely understood. But we don't go down to that.
Thank you. And I think that's actually all the questions that we have today. So again, thank you so much to everyone for joining us and for sticking with us through many technical issues. We really appreciate it. Don't forget to check out the changelog for this release. Definitely attend our upcoming meetup on April 24th, which you can also RSVP to by following this shortened link on the screen here. And of course, stay connected with us. Drop any other questions that you might have in the Modular community forum at forum.modular.com. And thank you again for being here, and we will see you next time.